Okay, which screen do you see? You see my note screen?
I see the note screen, the preview one.
Okay. Okay, let me stop sharing and I will share again. What do you see? Do you see the
Okay.
um,
I can see the presentation, the
okay,
slide
cool.
presentation.
Okay, cool. All right. Can see this up?
However, there is still a gray image that
At the bottom. Okay. Is it missing now?
Still in the middle, that one.
Okay. This is the best I can do.
Okay.
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 All right. So I'll stop sharing. So I'll stop sharing then. Okay. How do I stop sharing?
Alright.
Okay. Thank you. So I must go to screen 2. Okay. Right. Do expect some technical stuff. Okay. All right. Is the background too distracting? Do I move to my right or my left more?
I think it's okay. But do you want to use the background or don't?
Oh yeah, I'm supposed to use the background. Yes, yes. Okay. All right. Thanks for telling me. Okay. It's at our webinar punya GD, right? Do we have any attendees inside already?
Lalu dia kat rumah, maknanya dia pagi dongeng aja. Saya kawan dia nampak tak ada LOD dalam tu. Jadi tu kalau nak install software anything,
I'm unable to change my what do you call the my background. I think I have to log out and log in again. I think I'm not very sure. Mm. Oh, okay. Let's try. Let's try.
So you want to log out first, or you want to continue with this background?
Wait. Let me try to yeah. Let me try to browse for the background. I think I should have. The first name is BG. Maybe now. Oh, yeah. Okay. Okay.
Right, I can see the background changing.
Okay. Okay. All right.
Yes. Okay.
Okay. Thank you so much, Amin.
All right.
sure you could hear me? Is the lighting too bright for me? It's okay. Nanti orang komen apa buka airplane, kuda, apa pucat, whatever. Anything, text me, yeah? Thank you. Remember to record. Remember to send the survey form. Tell them every time must fill out the survey form.
Are you ready, Dr. Umar?
Yes, I am. Thank you. Yes, I am. Thank you.
Yes, right. Okay, shall we wait for another 2 minutes so that our attendees can get ready? Okay, Dr. Umar, shall we start?
Yeah, okay. Thank you.
Okay. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera, salam keluarga Malaysia. Jadi selamat kembali ke siri webinar 1 untuk slot yang ketiga untuk pada hari ini. Okey, jadi kepada yang baru saja bersama dengan kita, jangan lupa untuk isikan borang feedback. Lepas ini akan diletakkan link itu di dalam ruangan chat dan juga ruangan feedback itu akan digunakan sebagai attendance tuan-tuan dan puan-puan lah, dan melayakkan anda menerima sijil kehadiran untuk hari ini. Dan kita pun dah banyak dah cerita kita punya siri pertama ni berkenaan apa yang so on and so forth. So mana yang dah ada tadi akan dah dengar lah. Alright, kalau nak dengar, kalau dah terlepas yang pagi tadi punya slot, boleh sahaja tonton di dalam kita punya website review Okey, jadi tanpa meninggalkan masa lagi, ayo saya perkenalkan panelis yang seterusnya, iaitu Dr. Umawathy Techanamurthy, dengan tajuk webinar beliau adalah Innovative Didactical Approaches to Learn and Teach Within Industry 4.0. Without further ado, dipersilakan Dr. Umar.
Thank you, Fariza. Fariza, you may need to ask me the presenter privileges.
Dr. Umar, on you. Sorry for the delay.
All right. Hi, everyone. Let me just share my screen. Just give me a couple of minutes, yeah? Yeah, I don't think the technology is like collaborating with me. Just give me a minute. Ija, please tell me you can see my my
Yeah, I
screen
can
in
see
full.
clear. Crystal clear.
All right. Okay, cool.
Right.
Thank you.
Let's
So,
go ahead.
hello. All right. Okay. Hello everyone. Selamat pagi semua. Nama saya, I'm Dr. Umawathy Techanamurthy, and I'm a Senior Assistant Director here at the Instructional and Digital Learning Division, Department of Polytechnic and Community College Education. So today, I will be sharing with you on a topic very close to my heart, a topic that I'm still learning, and I believe there are experts out there who are also even maybe watching this slot. So feel free to chip in if you have ideas, extra ideas. Okay. So the topic is innovative didactical approaches to learn and teach within Industry 4.0. Okay. So this is the outline of my presentation. All right. So we'll start at a bit of fourth industrial revolution until way forward. Okay. All right. So what exactly is the fourth industrial revolution? The catchphrase that has been doing its rounds in business, tech, and policy circles, which in recent years has been popularized by Klaus Schwab, the founder and executive chairman of the World Economic Forum. Okay, so the origin of the term can be traced back to a 2013 initiative by the German government, and it was called Industry 4.0. It was a strategic policy to harness the rapid convergence of digital technologies, manufacturing, logistics, to build smart factories, right? To preserve Germany's global manufacturing dominance, okay? However, this factory-centric understanding of technology, according to Schwab, who describes this shift is an industrial revolution in its own right. Now, according to his view, the first industrial revolution, starting from the 1750s, used steam power to mechanize production. The second industrial revolution used electricity, to power up production scale. The third industrial revolution deployed electronics and IT to automate production. Now, the fourth one actually builds on the third one. So what Schwab describes is it is characterized by a fusion of technologies that is blurring the lines between physical, digital, and biological. However, unlike previous industrial revolutions, it is evolving at an exponential pace rather than a linear pace. Okay, all right. That's the book, if you were to read. It was published in 2016. And he says, we are at the beginning of a revolution that is fundamentally changing the way we live, work, and relate to one another. Right? So, ladies and gentlemen, which of these technologies do you think will have the most impact? Let's get some answers in the chat. Fariza, you may, just help me, just go through the chat if anyone is answering. My question is, which of these technologies do you think will have the most impact? So I'll give you all about a minute. Are there any answers in the chat, Fariza?
None at the moment. We'll give them time, I suppose.
Okay.
Okay. Proceed.
Big data. Okay, Sakina says big data. Okay. Thank you, Dr. Sakina. So based on research, the Internet of Things, which enables ordinary objects such as our TVs, I think Nur Hazira, yes, IoT, yes, the Internet of Things actually enables ordinary objects such as TVs and air conditioners to use the Internet to become smarter. All right, because this allows them to collect data and connect to other devices to make everyday tasks easier. So by 2025, the World Economic Forum estimates 26 to 30 billion devices in the home and workplace will be connected to the internet now and equipped with sensors, processors, embedded software. Of all 4IR technologies, IoT is set to have the most impact on industries in the future, as most devices will soon be able to collect or process data. So current research encompasses a variety of new IoT developments here. You can see energy efficient smart homes, smart city emergency response, wearable health monitoring. These are current research areas in the fields of IoT. With 4IR, the prevalence of robotics in society will be another notable change. Yeah, robots are already utilized in manufacturing facilities around the world, but the field of robotics is not limited to manufacturing. Recent developments include service robots to help people with vision problems, low-cost robots which assist people with grocery shopping, and autonomous robots that can inspect the structural health of nuclear plants and underground mines. All right. So another breakthrough is robots that are designed to work along with humans, and these are known as cobots. Now, these robots can make work safer and more efficient by taking on the jobs that can be dangerous or difficult to perform. Now, the healthcare industry is already using robotics for surgery, as well as to transport and manufacture medication. Yeah, but these applications of robots and cobots will develop further during this 4IR. Yeah, companies are still working to perfect driving cars, but 4IR breakthroughs will lead to massive improvements. Okay, autonomous vehicles could make transportation more efficient and safer for many types of vehicles. Now, with 4IR advancement, drones, buses, and underwater vehicles will also experience autonomous operation. All right. Now, another field is AI. Now, AI, just like what our previous speaker mentioned, is the ability for machines to learn and adapt to different problems and situations. So it's also called machine intelligence. AI is very versatile and can work in conjunction with IoT, autonomous vehicles, robotics, in addition to other advanced technologies. Now, automated customer service through virtual assistants and chatbots are already responding to us as customers, right? So that's already common. But AI will also be useful for many companies managing numbers and logistics, as AI-enabled devices can process numbers at a faster rate than humans. So you can see this, in your insurance, if you were to download your AIA app, it's all actually, it's already AI powered, right? So companies across different industries are already employing AI for a variety of tasks. Computers and machines are overseeing financial portfolios. If you check PwC's website, so you can see the AI behind it. They have the videos on that. We are also using AI to forecast weather and even planting crops. Now, as the technology develops further, AI's ability to learn and predict will allow it to be a solution to even more business problems. So even as we are talking now, Fariza and the audience, the capabilities of everyday technology is allowing people to operate self-driving cars, manage all aspects of their home from their phone, and get assistance from a robot for daily tasks. And manufacturing and other industries are becoming more efficient, providing economic growth while reducing resource consumption. Now, drones and advanced transportation systems has already, started delivering goods and services. With everyday tasks becoming easier, the ability for people to communicate and develop will also take a step forward, right? So, automation will actually help people escape, from the tedious tasks of their profession. And what this means is it's going to give you more time to be more creative and to address more engaging aspects of their job, right? So it's actually been Malaysia's long plan, to become a more digitalized nation, because this will not only boost our country's attractiveness in terms of doing business, but also improving the standard of living amongst the rakyat. So the National 4IR policy, the document, the one top left, the one blue color cover, the National 4IR policy actually outlines 4 policy thrusts and 16 strategies with 32 national initiatives. I think this one actually sets the directions for all ministries and agencies for us to align our plan in relation to 4IR and emerging technologies. Now, today we shall focus on Policy Trust 1, which is to equip the rakyat with 4IR knowledge and skill sets, and Strategy 3, which is to equip future workforce with 4IR skill sets. And this was also mentioned during our amanat with our Ketua Pengarah yesterday. All right. Now, to get there, the government has also launched the Malaysia Digital Economy Blueprint, the one, the pink color, pink reddish cover there, all right, which outlines specific strategies where the public and the private sector can play a role in making this a reality. Yeah, so the strategies are varied, encompassing, from developing infrastructure to creating an inclusive digital society, and most importantly, building a future-ready workforce equipped with the right mix of skills. Now, so we can see here, I'm focusing on S2 and S3 is under Thrust 4, which is focusing on competencies and digital skills to remain relevant. Okay, so this is the Malaysia Digital Economy Blueprint. Yeah, so this is an overall picture of it. Okay, so now, as members of the society, we need to be willing and adaptable to change. Yeah, in fact, workers and employees already, holding jobs have to learn continuously in the same way as people who are applying for new jobs. They have to enlarge and enrich their knowledge, and they have to acquire new knowledge, many are confronted with requirements out of digitalization, which is the theme of our webinar this time around. And they often have to do it without the help of a teacher. In many cases, employees are just left to their own devices. And that's the reason why we have to prepare our students for the challenges of our today's industrial world, making sure that they're able and willing to learn continuously, that they're able to acquire competencies independently, particularly when they are at their workplace with their colleagues. It is one of our main duties now to teach our students how to learn, to prepare them for the ongoing, self-reliant, self-directed learning processes of tomorrow, right? Okay. I hope y'all are actually, understanding the story that I'm trying to tell y'all today. So again, Klaus Schwab, the executive of World Economic Forum, you see his quote is, "Together, shape a future that works for all by putting people first, empowering them, and constantly reminding ourselves that all of these new technologies are first and foremost tools made by people for people." All right. So I think the core that I would like to sampaikan is we need to teach our students to be willing to learn continuously, so that they will be able to be prepared for the processes of tomorrow. Right? So this one, the competences of a K worker. Now, this is from Fit for Industry 4.0, Innovative Learning and Teaching for Digitalization and Automation, written by a team, Prof. George Spottel from University of Bremen in Germany, Parikam and Parionio. Okay, all right. So this book was published in 2021, just recently published. This figure actually shows us that knowledge workers need to have the willingness for lifelong learning. Now, they will not only need technical competence, but they also need that human and social competence as well. All right. So I'm going to give you all a minute to just have a look at this diagram. So you can see the importance of the core is actually lifelong learning, which is also outlined in our SDG 4. Yeah. All right. Now, in line with the increased automation and digitalization of work processes, organizations are depending more on employees with ICT specializations, especially those who can analyze big data. Like just now, we had an answer from Dr. Sakina. Big data is the big thing, yes? So that's what employees should specialize in. Making coding, developing application, managing complex database, yeah? So based on the empirical work of the European project Auto 4.0, now these following competences were generated. And these are called broad competences, or the new basics that you need to have. All right. So we have the new basics, which is this list. All right. And then we have the context-specific competences, which are like, okay, if you're working in a plant operation, then workers need to develop what? Problem solving, you need to understand the integrated system and its connection, you must be able to think and work across disciplines, you need to know how to get involved in new tasks, the application of IT technology as a tool, you know. So these are context-specific competences. And finally, these are the abstract competences, okay? So abstract ones are creativity, creation, critical thinking, communication, collaboration in teams, modeling skills, analytical spirit. You want to like find out why is this data behaving such a way, you know? So you model the data and then you try to analyze it. And then this data gathering and mining, respect of procedures. Okay, so that means there are ethics to follow, especially when you're doing data. So that respect for that procedures. Okay, communication skills, investigative character, always wanting to know why, how, you know, lateral thinking, curiosity, leadership, innovative management, vision and communication, and understanding business problems, right? So I think something that we need to ask ourselves as educators is, do our students actually have these competences? All right, so maybe Fariza, we can give the audience about a couple of minutes, you know, asking them what do they think about these competences. Do our students have these competences, and which competences do they have more? Is it the new basics, or is it the context-specific one, or is it the abstract competences one? Which one is the one that our students are ready with? And number two, tell me which one they need to work on. All right, Fariza, let me know if there are any answers.
All right, let's repeat the questions. Let's just type in.
Okay, so my first question is, which one does our students possess? Is it the new basics? Or is it the context specific or the abstract one? Which one do they have at this point of time? Because we need to bridge the gap. We want to know. Okay, let's say we have of abstract competences. Okay, then we can do this. Okay, so there's no Lailawati is telling me that they have new basics. Okay, good. All right, so you can see the new basics is how to master big data, how to use clouds, how to use data as raw material. Okay. All right, learning how to initiate innovations, learning how to cooperate and communicate better. All right. Sorry, I missed Dr. Nur Hazira's answer just now. What was her answer, Fazira? Fariza?
New basics.
New basics. Okay. So it seems that people are seeming to have the new basics, but not the context-specific competences and maybe abstract competences. These are things that we may need to work on. All right. Now, so now back to the topic, my topic today. So we have heard about Industry 4.0. I've already introduced you about what are the competences, but integrating that into our teaching and learning, right? So how do we make things simple? How do we focus on the fun? And how do we focus that the students, you know, learn what we intend to teach them, you know? How do you do that? Okay, so that's really something that we need to learn, all right? The issue is, Industry 4.0, right? It has been used in generating prototypes for research purposes, you know, final year research or postgraduate research or undergraduate research. But the integration of Industry 4.0 into teaching is still not well practiced. And this was a question that even Dr. Nana asked our previous speaker. Kenapa? Why aren't we, you know, using it in teaching and learning? So research shows that there are several limitations. First limitation is budgeting, the lack of knowledge, and difficulty in changing from the traditional pedagogy. And this was mentioned by Chong AR 2018. Yeah. So she proposed a model, a blended learning model for integrating Industry 4.0 into TVET teaching. Yeah, which consists of right, I think there are gray screens here on my audience. Okay. All right. Is my screen clear, Fariza, or is there any gray screens anywhere? Some more?
My view is clear. I don't know about the other attendees.
Okay, all right. So back to what was I saying? The integration of Industry 4.0 into teaching is still not well practiced due to several limitations. We have budgeting, lack of knowledge, and difficulty to integrate into traditional teaching. All right. So this is where Chong 2018, her team has done the research, and they have found this. All right. So let me just remove some of my notifications. Okay. So now from this model, what we can see is there's an importance in multidisciplinary collaborations. That means computer science department, you work with E&E department, all right? Or you work with the commerce department. So that's what multidisciplinary collaboration is. And then we have expert-led workshops. So this is where you get people from the industry to give you input, all right? And then we have, and this one is the one that instructors need to, we need to be trained lah in this context. How to conduct multidisciplinary collaborations and how to learn from, and what are we going to learn from expert-led courses and workshops, all right? And then we do the face-to-face teaching, we do the online teaching, but the blended thing comes. Okay, so what Chong suggests is a blended learning approach which uses flipped classroom with Industry 4.0. Okay, so I'll go to that in a bit. All right, so can you see in that yellow circle, in this Venn diagram, the yellow one? So she has mentioned that we can use simulation studies, we can do additive manufacturing, which is 3D printing in simple language, all right? And then we have augmented reality, advanced robotics, all right? And then we have like study about the environmental, societal benefits. You see, when you do a project, you tak boleh just simply do, you need to understand, how will this project impact the environment? How will this project impact the society? How will this project impact the economy? So this is something that students need to think, right? And this is also in line with SDG Sustainable Development Goals as well, all right? And then smart factories, okay? So let's look at the next slide. And in the next slide, this is where my, can you see, okay, this diagram? All right, this is actually adapted from my PhD work, all right? So my research was on flipped classroom in a TVET setting, all right? So if you can see, in a flipped classroom, for those who are not, not aware of this teaching approach, in a flipped classroom, there are three phases, all right? There's this what happens before class, what happens during class, and what happens after class. Now, the benefits of a flipped classroom is things that before this were given as homework for the students to solve at home are actually done during class, face-to-face, with the presence of peers and the instructor. That means lectures are actually, done before the class and not during class. So what the possibility of, of doing this is it allows the instructors and students to do the harder stuff, have more time to do the hard stuff. All right, because a lot of lecturers are saying, I do not have time to do my project because I have so much to teach, I have so much to teach. So what happens in flipped classroom is the teaching and all happens before class, but during class is the real learning that that goes through. Okay, so you see before class, so 30 minutes to 1 hour, through Telegram or a learning management system or using a 4IR technology, maybe an augmented reality app or something. So this is where you can deliver bite-sized materials. Bite-sized materials, sama ada lah, you want to give them videos ke, you not give them videos embedded with questions ke, different bite-sized materials for them to learn the concepts. And you have an LMS, a learning management system, to house the resources of the material. So in this sample, I used Schoology, all right? And then during class, what happens is there's this review of concepts you learn before class, because we need to make sure, we need to have a gatekeeper quiz to make sure that betul-betul student ni datang prepared atau tidak. So we need to, get them to review first. And then if perlu, then we do a mini lecture, right? And then after this is the hands-on practicum demonstration. So this is where you can do a real world, demonstration of something, or you can bring them to a field trip, or, let's say we go to a teaching factory, or we use AR, VR, MR, okay, which is augmented reality, virtual reality, or mixed reality, simulations of products or scenarios or robotics or 3D printing. This is where we do the fun stuff, all right? Or we can do problem-solving tasks or activities, group discussions on work processes. What are the work processes in the industry? We can, we can get that from the experts. Remember, if you refer to Chong punya work, there is these experts who are training instructors on how to actually conduct this kind of projects. Okay, so using big data analytics in class, using LWA, learn work assignments based on real work process. All right. projects with environmental, societal, and economic impact, scenario-based learning, project-based learning, or problem-oriented project-based learning. All right. So these are the fun stuff that you can do in your flipped classroom. And
Okay,
then, of
Dr. Wah,
course, yeah.
we actually have some responses from the attendees. Should we
Okay.
just chip in along the way?
Can you just give me 1 minute? Let me just finish
Okay,
this
okay.
framework first, and then I will take
All right, all right.
I'll have a
Okay.
question. All right. So once these problems are done, you remember about the competence, the other competence where you want your students to be able to communicate. You want your students to be able to work in teams. So all that can actually be can be nurtured using this, this approach. So that's why the presentation, the articulation, and then you get feedback. The feedback tak semestinya from the lecturer themselves. It can also be from the industry as well. All right. And then after class, then you can do reflection. Okay. Because our students are not really trained to reflect. Even us, we are not really reflective practitioners yet. But reflecting on what worked, what didn't work, what is the most interesting thing, what is the most fun thing, what is the most hard thing that you guys experienced throughout the class. So getting that reflection is also part of the learning. All right. So this is my take on flipping the classroom with Industry 4.0 based on my PhD work of flipped classroom in TVET settings. All right. So, all right. So Fariza, yes. Let's hear what the audience say. What question is it that they have?
Okay, there's one attendee, Puan Habibah. She mentioned about lack of digital technologies and also lack of data. And also from Dr. Y, I'm not sure of the name of Dr. Y. She asked about the kekangan utama adalah bajet dan etc. Adakah kita institusi atau pelajar telah bersedia berhadapan dengan isu yang Dr. sebutkan dan bagaimanakah mengatasi masalah tersebut?
Yeah. So Fariza. So these are the issues that memang dah didokumentkan dalam dah published lah. These are the journals. So I think it's something that we will need to take on. Yeah, we need to find a solution, how to get budgets, maybe from grants, getting a grant from industry, and then maybe that will help us in terms of budgeting. Yeah, but this is, of course, it's a, what I say, it's a bigger, we need the stakeholders to take this into consideration. So these problems are acknowledged, but I think quick solutions is to get industries to work with us. Yeah, so we have Majlis TVET Negara is actually working on getting industries to collaborate. So hopefully those projects will be fruitful, and then we can see these things coming true. Yeah, in future. I think it is in pipeline, Fariza. This whole plan. Yeah, it's up to us to speed it up now. Yeah.
Okay.
All right. So the title of my topic was the TVET Didactics, right? So didactics is actually a science of learning and teaching. And TVET Didactics actually deals with a specific area of training and education of the work process. Now, for people who have to cope with the demands of modern workplaces and lifelong learning, TVET Didactic must be related to the work process. And this is where I always suggest, even in my PhD work, I spend time in the industry to gather the work processes and try to get students to do it, at the college itself, for them to familiarize themselves with that, with those tasks, so that when they go to the industry, they are able to, adjust even faster, right? Instead of learning at the industry, they are already semi-prepared, right? So the didactical concept of learning and work assignments, LWA, represent project-based and employment-oriented learning. So we as lecturers, we will need to deal with contents which are related to our curricula, and then we need to actually sit with the industry and get this process done. Yeah, so it doesn't come from us. It actually is a collaborative effort between the industry and us, right? So let's look at this. So what are the core element and design of learn and work assignment? Okay, so as I mentioned, it's project-based and employment-oriented learning. Yeah, so we will need to brief our students on the up-to-date work process or activity in an enterprise or at a TVET center. All right, what the customers need for that project? What are the alternative solutions? What is the process of problem solving? What are the possible sources of information that students need to solve that problem? What are the orders for, if it's an individual work, what should be done? If it's going to be a teamwork, what should the order be? How are you going to assess them, in terms of self-assessment? how's the evaluation going to be done? Presentation, what do they need to present? What are they going to be assessed on? So there must be a concrete timetable. Is it a 2 weeks project? Is it a 1 week project? Is it a month-long project? What type of collaboration? Is it teamwork? Is it a partnership? Is it group work? And how should the documentation and reporting be? So this learn and work assignment is very work process based. Yeah, as I said, this is a TVET didactics lah. All right. So what happens is, and so this is something I got from Prof. Spottle, University of Bremen, via email. Yeah, he sent it to me over the weekend, and he tells that what happens is when we do this kind of approaches in our teaching and learning, it becomes very learner-centered, where students have to be self-reliant, self-directed. They have to be lifelong learners, active, autonomous. They need to have that semangat, you want to do something. And this is what is also needed at the workplace. And so we studied from the institution itself. And as an instructor, you change your roles. You become the facilitator sometimes you're the organizer, sometimes you're the coach, sometimes you're the advisor, sometimes you're the moderator, because I think based on your experience of doing projects at institutions, I think we can get the lecturers to give their feedback. What are the challenges? I think this is when you as a pensyarah, you have to tukar your role, when you are doing this kind of project. It's so easily said, but it's just not easy done. Yeah. So the didactical approaches are learn and work assignment, problem-based learning, project-based learning. So maybe Fariza, we can just give the audience a couple of minutes for them to share with us what are the challenges they face, when they're doing this problem-based and project-based learning, and how did they overcome it based on their experience? Fariza?
Yeah.
And yeah, okay. So I think I would like to reword my question. Are they doing this work process-based learning at the institution? If yes, why? If no, why? I think that's my question. Yeah.
Okay. Right, I'll type it in for a while. Hold on.
Yeah, sure. So I would like to know whether, there are instructors who have taken the initiative, right, to actually meet with industry and then, get down these are the work processes. For example, if you're teaching accounting and then the industry tells you, oh, this is the work process, the current work process. Now we are using AI and we're doing this. So this is how we do it. So this is the app, for example. I would like to know if, there are instructors already doing that.
We'll just wait. That maybe they are thinking for answers. Yeah,
Okay.
take the time.
If it's a yes, good. I would love to hear them share. If it's a no, it's okay, because we are still working towards this. Yeah. You see, so because this is what, if you look at this slide, this is what happens. This is from Prof. Portal again. So this is what happens, developing learn and work assignment, you see. So you have to identify that enterprise, and then you have to find out what are the processes, and then you have to check which processes are suitable for training. So not all processes are suitable for training. Okay, so that means maybe processes which are, okay, kalau dalam accounting, this is the process. You masuk syarikat A, syarikat B, syarikat C, the process is the same. So those are things that are suitable for training. And then you develop the learn and work assignments, all right? So, and this is where you have to work with experts, because the experts, the workers there will actually describe the processes roughly. Then they will suggest, okay, this is the list of the work tasks, and then, of course, the list has to be approved by experts, okay? Because you can see company A may have their own ways, company B may have their own ways, but there must be some standard ways of doing, of working, all right? I think I see some no answers, correct?
Yeah. Maybe they'll save it for later.
All right.
You can just carry on. Yeah.
Yeah, sure. Sure, no worries. Right. So when you're developing learn and work assignments, audience, you have to understand what is the content of the work. Is it inspection of something, or is it the quality of certain parts? What are the tools needed? Is it technical drawings? Is it sketches? Is it machine tools? Is it measurement equipment? What are the tools needed? What are the methods? Is it reading and producing technical documents? Is it production methods? Is it testing and inspecting the finished components? Yeah. So how's the work organized like? Is there a third-party contractor? Is it internal order, or is it done in a group work? So these are things that you need to think about when you find out our work processes. What are the requirements to be met? Like, can we execute the customer order according to the technical documents or models? Do we follow safety regulations? Are there any environmental protection regulations? So these are the things that you need to consider. So learn and work assignments are assignments for the students, but it's designed by the instructors together with the industry. So they're very related to a specific workplace, a working area. So these assignments are actually prepared for the learning process, and then we, of course, will add additional questions to guide the quality, and then yeah, so that's what we do as instructors, okay? All right, so I think so far I've covered what is learn and work assignment, and now it's time for me to show you all examples of what it means in a 4IR and learning, learn and work assignment. So in 2019, September 2019, the University of Bremen, they started a research project named Cora, which has a German, a very long word in German language, but nicknamed as Cora. Okay, the aim was to prepare employees at all levels for human-robot collaboration. If you remember earlier in my presentation, I mentioned about this term called cobots. So we work with robots. Okay, now the teaching and learning concept, what happens is they enables employees to view complex assembly systems holistically in order to recognize the potential of working with a human, working with a cobot, and how to use it. All right. So they used a software, they made a learning software using Unity, and they combined it with the learn and work assignments, but using mixed reality. All right. So the complex assembly scenarios were prepared within the framework of learn and work assignments, and this took into account the operational reality, okay, and the real work processes, which enabled project-based learning in realistic scenarios. Now, in particular, scenarios on the topics of safety, collaboration suitability, the technical feasibility of working with a robot, right? So initial studies indicate that there's this area, this is the gap in our actual teaching and training concepts, right? So this concept actually can help the trainers, the instructors, the employees, the supervisors. So it was actually a mixed reality thing. All right, let me show you how it works. All right, so this is the mixed reality what do you call a simulation of the project. Okay, so the introduced concept is based on the didactical concept of learning and work assignments, which represent project-based and employment-oriented learning. So all scenarios within the learning software, which I mentioned to you, is actually developed using Unity, uses an experimental modular assembly plant, nicknamed as EMMA. All right, it is actually a virtual environment. All right, so it's a virtual environment, and you can see here they are producing a wheel bearing. Okay, a baby labyrinth is produced on the plant. Now this baby labyrinth has been designed in such a way that it can be dismantled non-destructively. Now the assembly of the product requires the use of various joining processes, from clips to screws to the knotting of a rope, together with a possibility of a variation of the product. All right, now the plant as a whole is available as a virtual image and supports cyber-physical linking between a real system and VR environment. All right, the collaborative module can be used for several assembly tasks during the production of this ball baby labyrinth. All right, now one possibility is the assembling time lah. So this is where the robots will be positioned in a way that the employee can carry out the screw connections in an optimized manner, because the robot has already been programmed so that there won't be any collision happening between the robots and the employees lah. All right, so this is how you can actually train what happens in a real setting using mixed reality, right? Now, so with the intention of avoiding downtimes in production, yeah, we cannot do this in a real training center. So that's why they have done this in a mixed reality environment. So this scenario is actually, this example is actually how, if you do this in a flipped classroom, so instead of lecturing to your students about, oh, how to work in the industry, you can actually get them to experience the whole mixed reality experience lah, okay? Right. Okay, so one question. What is the name of that place just now? What is the nickname? It was a girl's name. Can you all type it in the chat? I just want to see whether you all are paying attention. Fariza? Are there any answers?
What's the name, eh? No, not at the time.
Okay. All right, I showed the answer already. It's like Emma, yes. All right, Dr. Nosakina, it's called Emma, okay? So the experimental modular assembly plant, all right? So if you're interested, then you can read about the paper. All right. So so now I'm going to show you more examples, all right? So data is the new oil. Data is just like crude. It is valuable, but if unrefined, it cannot really be used, right? Now, this was written by Humby in 2006. Now, data science is the sexiest job of the 21st century. It was written in 2012. Now, the problem is data are everywhere except in the classroom. Right now, these quotes reflect well the role that data science plays in a knowledge-based economy. All right. Now, these quotes actually suggest that data science is the key for the future, and developing countries such as Malaysia, where alternative paths to consolidate the economy are urgently needed, must recognize this opportunity. All right. Now, the need for data science, however, is not exclusive, just because of the economy. It's actually applicable for even for the societal development, reaching into every realm. Right. Now, the wide-ranging importance of data science has already been identified by the government, and there's already a discussion towards a national strategy on AI, which is currently underway. Just like in other developed, in mainly developed societies, we are also working towards that. All right. However, once the ability to produce data is in place, that's when we need to equip our citizens, right, the rakyat, with the tools to extract value from that data. So teaching data science should be a prime objective for societal development, and that's also our duty as we are in the academia. All right. So why? Because when we work with data frequently and repeatedly, our learners develop this experience, this competence. They'll gain fluency with data. So there's this excitement, for the ability to work with data. So not all students are going to be data scientists in the traditional sense. There will be many careers which will intersect with data science and scientists. So for instance, I mentioned a multidisciplinary, we need to work on a multidisciplinary project. So a biotech firm may pair data scientists with the product engineers and the managers. So imagine if the engineers and managers, they already have some existing foundation of data science knowledge, then this team cross communication, regarding data analytics can be made even more effective and productive, because it's an engineer who understands the data now. It's a manager who understands the data, and a biotechnologist who understands the data. So this is where a variety of career paths actually benefit from an early introduction to concepts in data science. All right. Right. So let's look at this now. This is an app. Let me just give you an example. Okay, Data Basic is a suite of easy-to-use web tools for beginners that introduce concepts of working with data. Now, these simple tools actually makes it easy to work with data in fun ways, so you can learn how to find great stories to tell. So, for example, because you might ask me, I'm teaching English. How do I teach students to do data? I mean, how do I do it? It's actually possible. Even you get them to interview few people, like say, get them to interview 3 people who were just involved, in the floods, for example, in December, and then we can analyze the words that they used. How many times the word sad, how many times the word, certain words came out. So we can use word counter, all right, to analyze the text. All right, so we have WTF CSV. So this is like a .csv file which we find in Excel. So even that You can do that, right? Let me show you about connect the dots. Okay, so this one, what you can do is in class, you can create a public Google spreadsheet and you share the short URL to your students, right? So bit.ly, bit.ly, data something, all right? And then you put there a header with name and restaurant, for example, and then you break your class into pairs of people and you ask each pair of them to talk about their favorite restaurants in their campus neighborhood. And then you tell each person, okay, you add 3 rows to the spreadsheet. That means the name of their name and then their favorite restaurant. And it's okay for them to have their same favorite restaurant as the partner that they are paired with, as long as they spell it correctly lah. So if it's McDonald's, make sure it's McDonald's and not McD. If everybody put MEKDI, then everybody, the other person also has to put MEKDI, because data, that will be McDonald's is different from McD, for example. All right, and then you can go to connect the dots here and then copy paste that person restaurant data into paste data tab, and then you can click the graph. Now when the graph comes out, your students will be able to it's data, right? But then you can ask your students, okay, so from this data, which of the restaurants you think which one is the most popular one, and the people that you're connected to. So for example, Fariza and I, so we may have a restaurant that we really like. So then we know, and let's say our good friend Fariza, let's say Akasha. So Akasha will say, oh, I would like to go to the restaurant that Fariza and Uma suggested. So that's how we pick restaurants. So, and this is actually very basic for why Food Panda, suggests certain things, or how our Shopee suggests certain things. So this is actually the basics of data. All right. All right, so that's one example. You can use an app as simple as this in your class for simple things. All right, so this is another example of Rojo, and he's a maths teacher at Venice High School in the USA. So what he did was he's teaching maths, but how did he use big data in maths? All right, so what he did was he asked his students to he said there's a study that in horror movies, right, male characters will die first, or they're more likely to die compared to female. So he said, okay, let's try this in our class. So he got the students to draw slips of paper, see whether they live or die, and then get them to arrange them opposite sides of the room, and then do that several times, and then reshuffle the stack of paper. And then he got the students to actually hero must die. Correct, right? So it's actually the guys are dying. So then he got them to calculate the difference between what is the male and female survival rate, and then see whether there are patterns in that data. Was it shaped by chance? And then get them to plot the dot plot, and then he used a tool called R to analyze and display and interpret their data. All right. So during that year, his students, they did statistics projects about themselves using their phones, to keep track of how they spend their time, what food they ate and all, but he used R. So this is how he actually has included big data in his maths class. All right. So what we want is, by working with data frequently and repeatedly, our students actually, they get that excitement, for the ability to work with data. All right. This is another app. It's free to use. It's called Code App. Now, it's called Common Online Data Analysis Platform. So it's a very easy to use data analysis environment. It's actually designed for kids age 11 and above. So that means 11 up to 18, 20. Yes, you can use it. What it does, it helps students to actually summarize, visualize, interpret data, advancing their skills to use data as an evidence to support a claim. Kan kita ada students yang just copy paste things. We don't want that. We want them to actually, get data and support their evidence. So what your students can do is they can load their own data into a very easy to use web-based data analysis tool to create their own data sets, and then they share their visualization, and then they discover their data-driven insights. And then this way, they will understand the world through data. All right, very simple to use, and even there are a lot of tutorials available for us as instructors to actually use it in the class. So I've given here this one. This is a 6 week. On your right, you can see, can we feed the growing population? So this is actually a 6 weeks project, and they're using data, and there's a lot of guidance on how to do it. So that's also very, very interesting. So this is how you can take your classes, your traditional classes, into a more interesting, how you embed 4IR into your lessons, right? So there's so this is an example. All right, let's look at another example. So this is another app called Tuva, but Tuva, they have the the free one and the premium one. So even Tua, they have like, okay, let's say you're teaching material science in the Polytechnic. So you want to teach them about the periodic table. So we every time teach them about periodic tables sahaja, but what if we can actually predict what will be the new element that's going to be, dijumpai dalam masa 40 tahun lagi or something. Actually, this one all can be predicted through data. So that's an example here. Periodic table meet the elements. And then we have data on using trash, and then what's the difference between Pixar and DreamWorks? Using box plots. I'm sure that in first year engineering in Polytechnic, I think y'all are, the statistics is being taught, box plot analysis, this analysis, this analysis. But what if we really give them real stuff to work in, simulations and all? I think this will make the lessons more interesting. All right. So it's a very famous question. I always my what do you call people always ask me, how do I start? I mean, which topic do I pilih? So my answer is always the same. What concepts your students are struggling with the most? What concepts you find it like very hard to teach? And are you like doing enough to make your lessons more relevant and engaging for your students? So you know the answers to this, all right? You know these the answers to this, and then you try to get apps that can help you do this. So most of these apps, they actually have well curated and interesting data sets. However, you may, like for example, Tuva, you might need to collaborate with someone who is a data scientist or a data whiz to develop the cross-curricular activities. So it's not only our students need to develop that skill of working with other people from a different department. We also need to, develop that skill, right? So never be shy to ask. So these real-world data sets is actually to pose authentic problems and tasks and actively engage students in the science and engineering practice. Okay, this so that they use data to understand phenomena and construct explanations lah. Right. Next example would be I'm going to go so I've covered a bit about data science. Let's look at augmented reality. So as the name reveals, this technology, Fariza and everyone watching, so it's actually an augmentation of reality, meaning that the real world that we're looking at will be enhanced through the addition of virtual elements, and the interactive experience through the AR allows users to feel as if they are affecting the reality. They are just actually manipulating something, but they feel that they are doing something. All right, they are actually manipulating something, and a computer generated effect. So in terms of education, research has shown that AR is believed to have potential to engage and stimulate students, nurture their creativity and imagination, and help to teach them concepts that are difficult or even impossible to experience. So the example that I've seen here, that I'm showing here, is service and maintenance augmented reality. So this is in a real TVET setting. All right. So let's look at this. So for example, if you're teaching mechanics in the Polytechnic, all right. So these are two screen captures, okay, from the mobile phone. Okay, with the application exemplifying the augmented reality lah. Okay, now the left screenshot, if you can see, shows the concept of a wrench tightening a bolt. All right. Now, there's actually a lot of mathematics involved in it. So what happens is these examples actually shows the vectors over the 3D models. So last time we used to do just calculation, right? I did Form 6 mathematics. We had to calculate, but we never knew why was the calculation for. I could never see in real life. If I change this, what happens? I never really bothered. I just did the maths. But imagine learning maths this way when there's an augmented reality part. And this was done by these researchers. If you're interested, then you can actually look at you can have a look at their paper. So what happens is when the user, he moves the wrench or the door handle, so there are two examples here, the vectors and the equations will change dynamically. So the user, they will input the magnitude of the position, the one in red, and force and green, and then with the sliders, the user can also modify the angles of the force vector with the circles labeled alpha and beta at the bottom of the screen. Finally, the user can play, pause, and rewind the application of forces in the system and watch an animation of the results being while reading the updated equation. So they can see a real, okay, if I change the magnitude of the position of the vector, okay, how it affects the tightening of the what do you call the wrench, how we use the wrench, and then the magnitude of the force vector. So this direct mapping between what is visible and what is computed, this is what augmented reality can afford us in learning, especially learning something mechanics, right? So for example, these are like, there are subjects in the Polytechnics or the College Community like, oh, sure, my students cannot score one, this one. It's not that they cannot score, sometimes they just don't see it in real world yet, right? So if you can actually use this, it will really help them. Okay, all right. So in this scenario, if you see on your right, what happens is the user holds the phone with the camera pointed at the image on the assignment, and the system actually uses the image to register the coordinate space of the world to render the augmented reality from the perspective of the phone camera. So the user can move and rotate the camera to appreciate and understand the scene from different perspectives. So the user can read the equations of the system at the top of the application, all right? And the user can change the setup, change the force, change distance, change angles using the interface at the bottom with the slides and the knobs. You can see the sliders, the red and green, all right, and the knobs. So when changing the parameters, the users can gain the visual insight, all right? So what do you, Fariza, so let's say you took this subject, during your undergrad or something. Don't you wish that you had something like this to better understand a difficult concept like mechanics, right? So this is how these examples were actually done on Unity, mixed with imported and pre-made models like the wrench and the bolt. These are things that you can actually just import inside in Unity. And then the arrow, maybe that one was modeled using Blender, another software called Blender. And then they had to create the scenes where they put the image. And then there's an AR app called Vuforia. I believe many lecturers actually among us have actually gone for those trainings, how to use AR in your teaching. And I mean, you have used the tool, like, okay, how to do things with Vuforia, but the question is how to use it in your own lessons. I think that's something that we need to be creative and do these kind of things, all right? Textbook, they can only show you the equations, but to visualize how the equations actually are working in the real world, this is where we need the power of augmented reality. All right? Okay.
Toma, I have a question that I'm wondering, because I'm not from the engineering background, so I'm wondering if students that is not from this area of study, kan, macam mungkin from services ke, things like that.
Okay, so here I have an example of how these authors actually came up with so we have fashion design, correct, in the Polytechnics, in the College Community. So they have shared how they have used simulations, 3D modeling software, some of the pillars in our IR of our Industry 4.0 for various fashion products, for garments, for jewelry and accessories. Okay, so this is a simulation of garments. Yeah, it's quite interesting. Garment simulation is to create virtual replicas of a garment, because if you're not a pro, you will end up wasting a lot of time and there's trial and error, which leads to material waste and labor. I think yang ni pensyarah fashion ya, kalau ada dalam kalangan kita ni, you can say, kalau budak tu salah potong ke, salah jahit ke, habislah material wasting and everything. So this is where we have advanced computer graphics that has led to a more reliable process of virtual garment construction. So these advancements actually try to simulate the whole process of garment from a concept to production in a virtual environment. So why did they do this? Okay, simulation is actually very important for the fashion industry. It's even been named as the heart of Industry 4.0 in the fashion industry. So what happens in garment simulation is, our standard method of pattern making, buat pola baju tu, we have standard human body models, okay? Tapi due to the differences that exist between human bodies, okay, so my body is different from Fariza. So sometimes baju that looks nice on Fariza may not look nice on me. So, it's like a poor fit. So what happens is these companies, they try to use their own method to create various items according to their target group, but by updating their sizing tables. So when they update your sizing tables according to the measurement for different people, you will get more people actually liking your product. So this is how simulations in garments, so companies are using this method to create various items according to that target group. So then they say, golongan yang umur 35 ke 39, their body shapes are mostly like this. So this is where we should focus on this kind of garments. So this is an example, as you mentioned, Fariza, if it's a non-engineering background. Okay, right. This is 3D printing. This is earrings, and you know, Fariza, like I use earrings like every day. I use a different pair of earrings, for example. So earrings are accessories used by women like me in our everyday life, and their shapes, colors, and materials vary. So in this work, inspiration was actually taken by flower models. Okay, so computer-aided design actually offers powerful tools for designing of jewelry. What happens is it reduces cost and optimizes the whole production efficiency. So if you can see on the flower image, the 2D concept was realized and then modeled on a web-based 3D modeling software called Tinkercad from Autodesk. And then these exported 3D models were further imported on the slicing software Cura from Ultimaker. And then it was 3D printed. And they used a material called polyethylene acid, which is a vegetable-based material, plastic material, and it's one of the most environmentally friendly material. It's fully biodegradable thermoplastic polymer, and is actually produced by corn and sugarcane. So remember, I mentioned about projects which are not only eco-friendly but sustainable. You know, we need to understand the impact on the environment. So these are the projects that we need to work on. Okay, so by taking inspiration from a flower image, a real flower image, to a 2D shape, 3D shape, and then at the end using 3D printing. So this is an example. Isn't this inspiring? And this was a paper published just last year. All right. All right. Even from walnut shells, they started producing jewelry designed based on walnut shells. Okay, so this is also a very creative design. So ancient Greeks, about 2,800 years ago, they found that walnuts are similar, like a brain shape. All right, and they're covered with a hard shell, like our human skull. So taking that into account, a walnut fruit is taken to create various products from it. So using 3D scanning, they captured the 3D shape of the model, and then they created virtual replicas of it. And then what they did was they actually created many variants. Okay, they created rings. Okay, they created buttons, they created a medallion, all right? They even used, a walnut. Just, can you imagine just a walnut? And they actually created different jewelries from here, all right? So I hope this has inspired you. So I just have one more example before I finish. So finally, we're going to cover artificial intelligence for predictive maintenance in rail car learning factory. So we have this course also in our under JPPKK. So this one, they use AI to actually predict the temperature variation and the remaining useful life of the wheel bearing of a rail car. And this study was conducted in 2020 using AI. So what happened was they got data, secondary data from the factory on what are the different temperatures of the wheel bearing within the safe operating limit, all right? So that they want to predict when will it degrade, when can we do the predictive maintenance, when can we do the preventive maintenance. So they actually wanted to making the operation of the rail car environmental friendly. So they used data from AI. There's an acquisition of data, then the pre-processing, and then they actually predicted, okay, based on this under safe use, in another 6 weeks and 2 hours, 6 weeks, 2 days and 2 hours, you will need to go for preventive maintenance. So this is how you can get data from the industry, and you can use it in your class to actually teach AI. All right. So I think that's all I have for now. All right, this one, way forward. Okay, so we need to move towards increasing the percentage of our teaching module to include Industry 4.0 elements. Core issues are mainly due to the limitations of insufficient knowledge and skills, our budgets, and maybe our scheduling issues. Because as I said, imagine working together with a computer science department and commerce department, there needs to be some scheduling done. And so those are issues, real world issues, all right? So even as our professional development, all right, it's also an important element for technological and digital transformation. There needs to be this transition period where we lecturers are willing to facilitate the process of changing our pedagogy and teaching practices comfortably. So a blended classroom that consists of traditional teaching, online learning, flipped classroom is suggested for integrating the pillars of Industry 4.0 into TVET to prepare better graduates, all right? So multidisciplinary collaboration, for instance, with the computer science department can serve as a first step towards implementing this approach. And once our instructors are trained, we can revamp our teaching materials to include Industry 4.0 elements, and students can learn via the blended classroom approach, which is a mix of traditional teaching, online learning, flipped classroom, with learn and work assignments, with PBL, scenario-based learning, project-oriented problem-based learning. So that's all I have, Fariza. So any questions? if there's time, but I think I've already overshot, I think. So thank you so much.
Yeah, thank you so much. Everything is comprehensive, padat, semuanya ada di situ. But if you have any further questions, maybe inquiries lepas ni, you can just directly PM Dr. Umar. She's always here in the IPD, insyaAllah. Okay, thank you so much again, once again to Dr. Umar. And seterusnya to the attendees yang baru saja join kita, jangan lupa isikan your attendance in the URL link that we have provided in the chat section. That will immediately lead you to the attendance and also the feedback forms over there. Okay, so kita telah pun sampai ke penghujung slot yang ketiga. So I hope our viewers, penonton, jangan lupa teruskan bersama kami selama 3 hari until this Thursday. We will be airing more topics, more interesting information for you to learn and understand. And with that, thank you so much. I'll see you again this afternoon. With more topics to be discussed. Assalamualaikum and bye.
Bye.